Okay.
Yeah. So two things lined up from our side. I ran into a conference talk from one guy from Red Hat talking about managing devices as CRDs, exactly what we talked about, and they had a workshop about it at one of the previous KubeCons, and I invited him to do a small presentation of the demo and the things they've done that, and maybe spark a discussion about it, because we talked about it a couple of times, but this is the only time I see that somebody actually did a POC and some working code in that direction. So it could be a good discussion. And the other thing is that we had also a guy using hooking up Eclipse Hono, which is IoT connectivity, to a Knative layer, and doing some things around it. Also, one of the topics we mentioned a couple of times, so it'd be good to present what I did so far in that area, and maybe spark some interest and see what we can do in that respect as well.
Yeah, I'm definitely interested, and maybe I'll bring some other people from VMware who are interested in those topics too.
Yeah.
On the one with the device management through CRDs, if they already gave a workshop or presentation, if they can put a link in the agenda, maybe I'll look at it in advance and have some more advanced questions if I can take a look at it a little bit ahead of time.
I'll put all these links in our agenda docs, I think, from both of the topics, and we can sync between us and reach to them to see what's the interest, and properly announced how to proceed with both of those, because I think.
And then the Hano feeding into Knative, I think what we were talking about there with Knative was specifically even a stream of events feeding, triggering Knative function calls. So is that the angle on this that they'd be getting at?
Sorry, I was muted and searching for things. Yeah, exactly that. So Hono connected to Knative, and then a demo basically having a video cameras taking samples as HTTP requests, one frame at a time, and feeding that into a machine learning function behind the Knative to do some recognition and things like that. It was
I guess
really
they can answer it, but I'd specifically be interested in how viable Knative is out at Edge, because I've heard people talk about using the Edge event stream, but then hosting function as a service kind of in a mezzanine tier rather than way out at the edge. Yeah. But I think it all depends on what your application and resource availability is, which makes the most sense.
So this is all about cloud side hooking up. So it's not edge related. It's pure IoT use case. So sending all the things to the cloud and processing it there. So maybe something we can see if we can do differently in the future and expand this experiment would be to bring more processing to the edge. But yeah. Throughout the meeting, I'll find the links. That there are a couple of blog posts on the topic, so it can be interesting to folks.
So I see someone on the joined with the initials QA, which I don't recognize. I'm just asking because those EdgeNet people may show up during the call, so I wanted to see if that might be one of them.
And yeah, maybe Kevin wants to introduce himself as well. I'm not sure if.
Hi, I'm Kevin Wang. Currently working on KubeEdge. I just joined to want to keep up to date.
Hey, welcome.
So where are you based?
I'm based in Hangzhou, and currently I'm working in the office, so I need to wear a mask.
Oh, okay. So aside from that, nobody came there except for the EdgeNet, which might not show. We didn't have anything on the agenda, but if anybody here on this call wants to bring up a topic or just tell us about something interesting you found lately, and we'll see where it goes.
So one of the things I would like to discuss is how we proceed in the absence of the KubeCon. So do we want to go and maybe even intensify our activities online? Maybe, you know, continue with the survey and do something virtually.
Yeah, even though the goal of the survey was to cover the results at KubeCon, I don't see any reason why we can't do that out of band. I think that the talk we were going to give there, at least in theory, it's still scheduled for as early as July. So I just as soon leave that rather than put it on the air and then have to do another one. In terms of other activity for the group, I'm not sure. Bringing. I think that we could do a better job of getting things on our agenda in advance. Now, we've had a few that dropped off, but it almost seems like people who drop off are becoming common enough that we need to have a buffer of maybe 2 topics per meeting to make this work well. Certainly, if you can bring that Knative talk, that's come up a couple of times at least, and I don't think that's actually been covered very much anywhere. So that one is actually a really interesting topic. And I've got some people at VMware who are working on Knative, not specifically for Edge, but I think they'd be interested in that. And I can, especially since the next meeting is in the North American time zone, I think that I can likely get them to show up for that meeting.
I'm just putting up the links in the agenda doc for the future reference. So yeah, I'll reach out to the folks who did it again. So they were interested. It's just depending, I think, on the time.
Yeah.
When
I think that's a big enough topic. We could go several meetings just because there's once you start feeding things into an event stream, there's a lot of potential IoT and Edge event streams.
Yeah. So I put it all in there. So Kubernetes of Things talk, that's a CRD, which a topic which I found very interesting, and 2 blog posts about hooking up Knative to an IoT layer, but in the cloud so far. But yeah, we can start from there.
And for a future meeting, I'd still like to get an update from Cindy on, well, she had the project she was going to talk about, but even the Azure Edge sounds interesting to me. And I know that KubeEdge has its own CNCF working group, but I haven't seen an update on KubeEdge myself for a while too. So if people from Huawei and FutureWay want to sign up to give us a briefing on what's new, and or if you have had any recent releases or have one coming up, maybe you could pick an agenda slot to cover that.
Sure. We just had a release 1.2 is February. So let me post the link. we have a, and also we are going to build last week there's a Crano TSC meeting. We plan to build a blueprint project, basically show end-to-end things for the Crano. So to present a KubeEdge into Crano, and let me post my release. Let me find that. We have the release 1.2. There's a couple new features. I don't want to go too much for the details, but we are moving on from now the KubeEdge plan to have a 3-month release along with the Kubernetes. So about a month behind after the official Kubernetes release, that's give us about 4 weeks to update the dependency on the Kubernetes. So we just updated in the release 1.2, we support Kubernetes 1.117. So we plan to, at the beginning of May, we are going to release a 1.3 that will support Kubernetes 1.18 release. We're going to have a minor release between. So this major release in 1.2 is the Edge node auto registration and the Kubernetes upgrade. Also, we upgrade our Go support to 1.113. So we are going to use ULAN. We support Golang 1.113. The major upgrade is the cloud native transition reliability. We have a few support support update. Let me see what else. Let me post this copy link address in the chat. I'm putting the change log in the chat window. Is the
okay, I see it.
Yep.
I'm going to copy that over into the meeting notes too.
Yeah. So from now on, we are going to have a regular release for KubeEdge every 3 months. It may shave a couple of days in case of scalability, code stability issues. What else? So yeah, for now on, we just had the community meeting today about 3 hours ago. So we discussed a few release issues in 1.3 release, and one major things we are going to do is a Crano blueprint project.
So does a Crano change much? You correct me if I'm wrong, but I think KubeEdge started out more with a device edge focus, and then a Crano, as I understand it, is more for
technical
software-defined radio management, or am I wrong about that?
I post another link. Is our blueprint. It's basically we want to do a we are at the very beginning. It's more like a IoT Edge, but we are trying to cover some of the enterprise edge or technical edge. So this blueprint is more like the offloading. So it's still working in progress. So the thing is, we want to do some mobile machine learning or inference offloading to the edge. So before that, there's a company called Mobile Edge. It's called Mobile Edge or EdgeX or Mobile EdgeX. Mobile X? Yeah, Mobile EdgeX is a startup in San Francisco. It's a Deutsche Telekom founded. So what they do is they offload their machine learning directly to the cloud, but they have some restraints. So we have a new, we collaborate with them, going to use the KubeEdge to build a new offloading framework or blueprint. So basically, the mobile device will offload some inference to Edge. If Edge cannot do it, it will offload the inference to the cloud, and also the training will be happening cloud, or the edge is all the offloading stuff. So we are going to build this reference framework in Krano. So hopefully that will help the industry to have a sample framework. So I post the.
Okay, and I moved it over into the notes.
Yeah, I also put that. So that's ongoing.
I'll take a look at it after the meeting. I'm just a little curious.
So yeah, that's pretty much, yeah. Do I miss something, Kevin? Kevin just.
I just want to add that KubeEdge started with managing nodes at the edge, and currently for a bit longer term, we are trying to support managing clusters at the edge. And what we're thinking about is that the KubeEdge provided a unique thing different to the other projects is that we support the metadata synchronization between cloud and the edge. So for managing clusters at the edge, we probably will design something like federation, but the different thing is that federation, Kubernetes federation implementation kind of result in using ListWatch, which we think it's not a good format. I mean, not a good way over low bandwidth, high latency internet. So
it uses what kind of storage?
Sorry?
You said it uses storage. I missed the word.
No, I mean, the Kubernetes Federation, KubeFed today, the connection between member cluster and its control plane is ListWatch. So ListWatch is typically regarded work well inside data center network, but it can not work very well over internet. So we will probably re-implement that. So currently what we not yet decided is whether we reuse the API from KubeFed or not. That's one thing we are still investigating. Another thing is that we're trying to deal with the service discovery and the service communication between applications located in different subnet or applications between cloud and edge. The hard thing is that that sometimes the applications are in the private network. So one first step will we will try to introduce the gateway for each. Typically, we have a gateway for each subnet and route all the requests through the gateway. So the gateway will have a public IP, so they can talk to each other through different subnets.
So let me see if I understand this. So by cluster at edge, that's a full Kubernetes cluster with its own control plane, its own API server, its own etcd. And then potentially one of the issues with that is even version drift, where, who upgrades first? Can you operate federations of clusters when some are at version 16, some at 17, for example? For interactive services, when you say join the nets, are you looking at service mesh to do that, like Istio or some other service mesh, or just counting on regular?
Yeah, so currently we have two plans on this. So because user may not want to have service mesh, or they may want to have a service mesh, but we think that if they have service mesh, the functionality is much more powerful. So in the case with service mesh, we are trying to implement the Istio gateway API for that. If without service mesh, I think Kubernetes also are discussing about gateway API, so we will probably follow that. Otherwise, we can first try to implement the ingress API at the edge.
Yeah, the one thing that I think in some edge applications that is perhaps, you know, unfortunate or problematic with using Istio is that if you've got intermittent connectivity to these edge locations, maybe you don't want it to be HTTP focused as your protocol, you know, your prime protocol for that service mesh. And if you could get something mesh-like in terms of management and offloading, writing the network and security code in your app, you know, the sidecar thing, but maybe use protocols like MQTT or something a little more tolerant of intermittent connectivity. I think that's something that, at least in a lot of these edge things, the world could really use if somebody was to build it out.
Yeah.
We just don't want to reinvent the wheel. We want to leverage the existing. Let's see how it goes.
Yeah, there are a few non-Istio service meshes out there that have taken slightly different approaches, like the one it is literally called Network Service Mesh and a CNCF project. And I think that was geared to go down to L2. And there are a lot of telcos, I think, who are looking at that, maybe participating in the project. But I don't think it's a message queue like mesh, or maybe I'm wrong about it. I'm not an authority on it, but I certainly am aware it exists, and that in the telco space, there are people looking at that one.
And yeah, shameless plug from my side, the Red Hat Scupper project we presented here as well, which uses AMQP as a messaging backbone for doing this, and basically going in the other direction than the network service mesh on the layer 7, and dealing with discovery of services on the level 7.
You say it takes on all the features of an Istio service mesh in terms of service discovery, security, and observability, meaning it and load balancing, if there is such a thing relevant to it.
Yeah. Most of the stuff, because it's done a little bit different approach than the traditional service mesh, but it does a similar thing in other terms that yeah. So the service discovery usually in the service mesh land is done using DNS. So level 3 by using something like Scupper. So layer 7, basically services on their own use their own addresses to subscribe. So it's a publish subscribe kind of communication patterns. So you can lay over different things on top of that, but you're not dependent on resolving things on the DNS layer to find things, and you can do some interesting things. I saw a couple of interesting demos, like doing multicast HTTP request response, where you're having those sidecar proxies to do transformation between the HTTP request to basically a message into the AMQP network, which that is then multicast to multiple services listening to that. And you can do that once you're in AMQP network, right? And then you get multiple responses back, and you basically just do a multi-form response back to the client, which is an interesting use case.
Well, I think if you have a sidecar architecture, that alone is a big win, because I'm a strong believer in the principle that your standard app developer isn't it's tough to find an app developer who's also a security expert and a networking expert. And if you can split those apart so that your app developer focuses on the unique aspects of the app, there's a lot less that can go wrong. And it tends to translate into a lot less security incidents and exposures. So to me, if you want to call it a mesh, even for some specialized protocol, that's one of the key features that you want to have to, to say have Istio-like advantages.
Yeah, you're hitting your local HTTP from your service, right? And you don't care what's going on after that.
It's interesting. I read about they recently had a new release of Istio, and at least the press coverage described it as going back to more monolithic, like they broke it up into too many pieces and went back the other direction. So even though that Istio is made to support microservices, maybe they went a bit too far on their own internal architecture. And I have yet to go deploy that to play around with it, but that was rather interesting. And I still remember some people at KubeCon North America making some snide remarks about how many CRDs Istio required. I think somebody called it 1 million, which was obviously an exaggeration, but it was a lot. And, I guess that's another aspect to keep in mind. If you try to bite off a mesh-like undertaking of handling networking for an integrated edge with many nodes feeding back to cloud or mezzanine.
Did you look at an announcement as well that they added WebAssembly extensibility support in Istio? I didn't get into the details, but
yeah, I really have just read about it and not gone and deployed it. It's been a while since I touched it. I got pretty familiar with it last year because I gave a talk on Istio Mesh expansion at Open Source Summit Japan. But since then, I haven't gone back and refreshed what I have loaded in my own Kubernetes cluster.
Yeah, it'd be good to try to find somebody.
I can think of another topic I'm curious about. If I really don't even know who we could get to talk about it, but deploying Kafka, feeding streams originating from Edge is something that I'm kind of curious about. If we could get a user who's put that together, or an open source project doing that, or
we have done that actually. We build a little, let's say, agent for manufacturing machines, which talks to a Kafka broker. And the trick behind it is that you basically have this agent sitting on the machine, and you can just dump all your data onto the agent. You send it away, and the schema of the Kafka message is inferred online basically, and then stored in different databases. So you can just like dump video data on there, you can dump metadata, you can dump time series data, whatever on there. And then a Flink process kicks in, basically watches the stream and then channels it into the different databases. And depending on the network traffic, it also applies different kinds of, let's say, network compression techniques and batching. So when your average load in your network gets higher, the Kafka talks to the agent and says, okay, we have a very high bandwidth situation right now. Maybe you should start sending less messages and try to compress more. And when the network is free, it starts, let's say, like freeing up all these resources and says, okay, you can go full latency now and just pump out everything you have.
So that's compressing what for your application? It's compressing
It depends on the metadata or on the schema that is inferred. So it switches the compression technique depending on what you put into the agent. So video data might be compressed different than time series data, for example. Mm-hmm. And you can basically plug in different compression algorithms in there, which you can like switch around. But this is like really early stage right now. So yeah.
But is there something running on the edge that consumes data from Kafka and doing all this forwarding, or?
Well, basically, our edge device in this case is a manufacturing machine. Mm-hmm. So it's like depending who you talk to, the edge moves.
Yeah. No.
So we are basically managing this agent with Kubernetes. Mm-hmm. And right now we're still in the making of how to integrate it actually into the machine, because a lot of machines are running on Windows and that doesn't play that well with Kubernetes at the moment. So we are probably setting up VMs on the machine itself to just get like a node inside the VM joining the cluster, and then you have like this, let's say on-node communication going on the machine, and you can just dump all your data on there, and then it's gone, and you don't have to worry about it anymore.
So, but then Kafka is not on the machine. Kafka is in the cloud, right?
Yeah, exactly.
Okay,
yeah.
But in terms of feeding into Kafka, I can appreciate this. Going back all the way to the 90s when I worked in industrial automation, I remember building into the product I was working on an ability for data streams to do what you're describing as compression. These were sensor readings, but it turns out that you've got a couple different problems when your network gets congested, or even when there's a bog down in the receiver on the other end, which can occasionally happen, where if you've got time series data, say that's at 1 second intervals, but you filled up any buffering and you know you can't get it to the endpoint yet, you'd prefer to take it to 2 second intervals, for example, by averaging it down and then throwing out some of the samples. And it got pretty complex where you'd even take a look at it, and if any samples were outliers, which might indicate alarm situations, say they were several standard deviations out of norm, you would leave those in the stream, but average down the rest of them so that you wouldn't lose the anomalies. And there was also a technique used of back pressure where the consumer could, sort of like the old days of Hayes modems with X on, X off protocol, of telling somebody, look, you need to slow down. I'm not able to consume at these rates, so please change your, please downgrade your sampling rate. And it was actually a pretty interesting piece of engineering. The company ended up getting patents on it that have, because it's so long ago, they're expired by now, but there was enough there that there was some real invention going on to get that to work for typical industrial automation applications. And I could see that, how that would fit into Kafka or some other stream of time series data.
Yeah. I think like the biggest problem we are having right now is just the data velocity. We are basically up to we have sensors which produce up to 3 megahertz per second. Mm-hmm. And that's just so much data that we can't get rid of it. And that's like basically the biggest problem at the moment. Like, how can we actually, first of all, analyze all this data online? We have camera systems which produce 15,000 pictures per second. So that's like enormous task to just write programs that can actually handle that kind of stuff. And then you want to get away with all this data. And what I always see with Kafka is like it's breaking down at around 15,000 messages per second from one node. It's just like crumbling down, I would say. So somewhere around there, depends on your batch size, of course, but it's like a real challenge, like what to do with all this stuff.
Yeah, and a lot of these protocols, like take TCP, are made just to engage in heroic efforts that ultimately you might not want with time series, because at some point you'd rather, you always have finite buffering capability, and at some point you have to come to the conclusion that, look, I don't want you filling my buffers with all this stale information. Beyond a certain age, it's no longer of interest anyway, or I'd like to have it compressed down. But it almost amounts to a situation where you want to control the buffer so that if the buffer built up, rather than being in a protocol you can't get your hands on, you want to go in there and alter the data that's been queued, making your own determination on what gets thrown out or replaced.
I think one of the key differences is like basically the push of data or the pull of data. Like you kind of shift around the responsibility of who takes care of the data. I think Kafka is like this broker system. So as soon as I put something on the stream, I'm not accountable anymore for this piece of data because it's just gone. I don't have to worry about it anymore. Other technologies,
I suppose any of those that are pub sub too, by design, they hid the consumer from you. So the ability of the consumer to give you this signal that, look, it's coming too fast, please change, sort of ruined by a pub sub protocol. Because
exactly. On the other hand, you have like these collector stuff like Prometheus or other scraping technologies, like, I don't know, I think FluentD, for example, does something similar, where you kind of just scrape the endpoint, and there's a responsibility, of course, lies on the device that is producing the data, not to drop anything. So it kind of depends on where you want to put your buffer. Like, do I want to put my buffer onto the cloud with Kafka, for example, or do I want to put my buffer on the edge device and handle that for myself? So like these two differences. Of course, depending on the data stream you have, you can have like hybrid ideas, you know.
But anyway, for a future meeting, I think we could do a meeting on Kafka. I don't know if you'd want to do it, or if you know authorities out there we could approach and recruit. But that might be an interesting topic, and it would feed potentially into Knative ultimately too, because I think a Kafka feed to Knative is a pretty common act.
Yeah, we have done like Kafka in combination with Flink, I think. I'm not quite sure what they did with Kafka internally. So we did like a comparison of Kafka compression mechanisms and our own compression techniques. But I'm not so. I didn't set up Kafka myself, so I'm not quite sure what we did there. So depending on what you want out of this presentation, I might pass to somebody else. Yeah. So I'm not that firm on Kafka itself right now. So. But sure.
Cool.
Well, we've still got 15 minutes to go by the schedule, but does anybody have anything else they'd like to discuss or chat about? Put it out there, otherwise maybe we should just end it a little early, but
That's all from me.
Okay,
Yeah, that's good.
you've got
Me.
the recording, so if you want to declare it to be the end till next time, go for it.
Yeah. Yeah, see you all in 2 weeks.
Okay.
What
bye.
else to say? Yeah.
See you.
Take care, everyone.
Bye.
Keep safe.
Bye.
Bye.